using a string variable. A specific example is making a game that is controlled by the keyboard. The program needs to recognize the character that is pressed and translate that into carrying out some function. Now, strings can also hold one character, but chars can't hold more than one character, so keep that in mind when defining variables. Now, why are variables so useful? Well, being able to store information in a format that can be easily referenced later is essential for any good program. Oftentimes in code, you're going to want to keep track of things such as a user's name or score, and so by creating a variable called name or score, you can store this information in the variable and then reference it, add to it, or modify it. Also, many times, the program will want to take input from the user, which cannot be pre-programmed into the code, and thus a variable is required to store the information. A program may also rely on factors that will change as the program progresses, in which case a variable is once again required. Also, taking these variables and manipulating them is quite necessary for carrying out many of the tasks you want a program to carry out. For instance, multiplying int variables or concatenating string variables. Overall, variables are the backbone of any good program, and you'll find yourself using them often if you want a clean and efficient code. So it's best that you learn what types of variables you need to use and when.
So now that we know all about the different variable types, and we've talked about them a little bit, we're going to delve further into what happens when we actually define or create a variable, how we reference them, and how we can manipulate them for our programs. To start, let's go over what happens when we actually define a variable. Now, when we write a line of code which initializes a variable, and that code is executed, the computer essentially creates a little space in memory that stores your variable name and its contents so that it can be referenced later. Going back to our cardboard box example from the previous segment, think of this as if you had your own storage facility, and you make a new cardboard box labeled name, and inside of it you put a piece of paper with the word null pointer exception on it. Now, anytime you want to know the contents of your name box, you could simply look inside and see that it has the contents null pointer exception. This is what the computer does, except the storage facility is the memory in your computer, the box is a variable, and the contents of the box are whatever the variable is set to be equal to. Anytime you want to know the contents of the name variable, you can simply call it, and the computer will pull the information that is stored in that variable and use it how the user sees fits. Another thing to note really quickly is that you can actually make a variable without putting information inside of it. This would simply be like if you built up a new cardboard box, gave it a label with a Sharpie, but just didn't put information inside of it. You're simply saving that space in your storage facility for later. This could be maybe because you want to store information in it later down the road, or if you're going to use it to store information given to you by the user, in which case you can't give it information since you don't know what the user will input. Just a note that if you try to reference or point to a variable which does not have any information in it, you'll get what's known as a null pointer exception, which despite being an amazing name for a YouTube channel, is something you generally want to avoid when programming. Now, programming languages allow us to do some pretty cool things with these boxes that we've created. For example, let's say we created a second variable called channel name, and instead of setting it equal to null pointer exception, we instead set it equal to our already created name variable. This doesn't create a space in memory for this new variable, however it simply points to the same location of memory we have already created for the name variable. Going back to our storage facility example, this would be like instead of creating a whole new box labeled channel name and storing a sheet of paper with the word null pointer exception on it, we instead simply added another label below the name box entitled channel name. Now we have two variables which point to the same contents, that being the string null pointer exception. We usually do this to save space in our code for things that we know are going to have the same value. Variables can also be updated throughout your code. For example, let's say you had an age variable, and inside of it was the integer 17. Then, you celebrated a birthday and wanted to update your age. All you would have to do is reference the variable and set it equal to whatever new integer you want the variable to hold. In this case, 18. This would be the same as having a box labeled age with a sheet of paper reading 17 inside of it, and then taking that piece of paper out, erasing 17, replacing it with 18, and then placing it back in the box. Doing this, we are able to easily update the contents of our variables throughout the code as things dynamically shift. As another example, if you were making an RPG, your character would likely have stats such as attack, defense, mana, etc. As the game progressed, you could continuously update the variables so that the player could get more powerful the further along that they went through the game, and you wouldn't have to create new variables. You would simply need to just keep grabbing that box from your storage facility, erasing and replacing the numbers on the piece of paper, and then continue along with your code. Just keep in mind that these variables are nothing more than places in memory in which a certain value is stored, so we can easily update the numbers and their place will remain constant. After the code has run its course, the place in memory is deleted until you run the code again and the program dedicates space for the variable again. Each time you run the code, you're making new boxes in your storage facility, and at the end of the code, you destroy them all to make room for the new boxes next time. Another cool thing you can do with integer, float, and double variables is add them, subtract them, divide them, multiply them, and even modulus them. For example, if you were making a calculator app and you stored the first number the user entered as number 1 and the second as number 2, you could then multiply num1 and num2 together and either print them or store them in a new variable entitled result. Then, each time you run the program, the user could input new numbers into the num1 and num2 variables, and they would simply be set to those new integers that the user inputted and return the result that corresponds to those specific numbers. This allows you to keep easy track of which numbers are which and what's going on in your program, which is extremely useful. Also, while you cannot subtract, multiply, divide, or take the modulus of strings, you are able to add them, like we said previously. Let's say you had a string str1 with the contents hello, and a string str2 with the contents there. You could add str1 and str2 to create a string that had the contents hello there, either storing it in a third variable or printing it out to the console. The last topic we'll be covering on the topic of variables is the naming conventions of variables, which albeit may seem odd, but it's extremely important when trying to read your code, so we'll be covering it now. Now, variables have to be one continuous string, and so if you wanted to make a variable that stored the player's score, you'd have to find some way to combine the words player and score, since you can't have the phrase player score be the name of a variable. All programmers have their own personal preference when it comes to naming variables, but the one we'll be using in this lecture is called camel case, which is the process of not capitalizing the first word, but capitalizing every word that follows it. Going back to the player score example, using the camel case method, the variable would be called player score. This allows us to easily see and identify each word and becomes really useful for long variable names, like the player score before the final boss. Whereas if we just type it out without camel case, it would be really confusing and hard to read. This will help you out a ton when we start finding bugs in our code and need to quickly scan through our program to figure out what is wrong, and adds to the overall readability of the program. Other programmers might use different naming conventions, like using underscores to separate the words in a phrase, but for now, in this series, we'll be sticking with camel case.
Next, we'll be moving on to conditional statements, which at their core are statements that change the path of our code depending on certain conditions. For the sake of keeping things simple, for this section, red lines will connote that our code will not be following the specific path, and green lines will mean that our code is following the path. The main type of conditional statement that programmers use is the if statement, and this will show up countless amounts of times in any program you write. It is as simple as it sounds. If some condition is true, and usually that condition will be enclosed by braces, then carry out the instructions located within the if statement's brackets. Else, do another thing. Now, brackets are used in most programming languages to indicate a segment of code which will run. It works like this. If the condition in parentheses is true, then all of the code contained within the brackets will run, and if the condition within the parentheses is not true, then it will skip over all of the statements within the brackets. A quick note is that while this is the case with most programming languages, some, like Python, use colons and whitespace to determine where a piece of code starts and ends, but for the sake of this series, we'll be using curly braces. Now, the condition within the parentheses can take on thousands of different forms, such as if the value of the string variable name is equal to Stephen, or if the player's score, stored in an int variable, is greater than 5. The list goes on and on. Each of these statements is evaluated as a Boolean, which you will remember from when we talked about variables, is either true or false. If the Boolean is true, we run the code inside the curly braces. If it's not, we pretend everything inside the curly braces never existed and move on with our code. The if statement comes with two more additional statements that can go with it, else if and else. else if is a conditional statement used directly after an if statement, and carries out mainly the same function as an if statement. However, the else if statement will only be evaluated if the preceding if or the preceding else if statement is bypassed due to its condition being false. So we would run through it like so. If something is true, we would run the code inside of that statement's curly braces. Else, if that something is not true, but another statement inside of the parentheses is true, we would then run that code segment. And if neither of them are true, we would skip both segments of code and move on in our program. This can be a hard concept to wrap your head around, so let's do an example. If we had a program that evaluated the if statement if age is equal to 10, we could then have a statement under that which stated else if age is equal to 12. Now, if the age variable was 10, which we can see from the example that it is, then the code immediately following that conditional statement in the brackets would run. The else if statement we made will not even be tested, since we know that it is going to be false, and thus the print statement inside of that conditional statement's brackets will be ignored, and the code will move on to the rest of the program. Now, for example, let's say we change the age variable to be 12 instead of 10. Now, instead of the first conditional statement being true, it actually evaluates as false, since age is no longer equal to 10. So what we do now is first skip over the print statement, which prints out that age is 10, since it's not. And then we evaluate the else if statement. We check if age is equal to 12, which again it is. And so now we run all the code inside of that conditional statement before finally moving on to the rest of our program. So, as a review, we check the initial if statement. If it's good, then we run all the code within that if statement's curly brackets and move on with our program. If the initial if statement is not true, we then move on to any else if statements and evaluate if those conditional statements are true. We can have as many else if statements as we want, although this could lead to clutter amongst your code, so we'll talk about some alternatives later to help this out. Now that takes care of the if-else statement, so now we'll move on to the else statement. The else statement, once again, comes after an if or an else if statement, and will carry out its instructions no matter what, as long as the preceding statement/statements are evaluated as false. If we went back to our previous program, we could add an else statement, which would only have the code in its brackets run if the age variable wasn't 10 or 12. This will catch all cases of the program that didn't fit into our parameters. It's good practice to always have an else statement at the end of your conditional statements to catch any weird cases that may come up in your program. Now remember back to the fact that we could have thousands of else if statements. After a while that can get pretty cluttered, and so another very useful conditional statement which helps circumnavigate this problem is a switch statement. A switch statement is functionally similar to many if and else if statements together. You write a switch statement in the form of switch variable, and then below that you write out how many cases the variable could be. For instance, if we wrote switch var, and then under it we could write out 5 cases that the variable var could be, and then the instructions listed under each case would be carried out if the var variable would be equal to that case. Now switch statements are different since instead of using brackets, they use a colon to signify the start of a set of instructions and a break statement to end them. This is very useful because you are able to essentially use many if and else if statements without having to write nearly as much. In switch statements, you just always have to remember to include default case at the bottom of the expression to denote any and all cases that don't meet the above requirements. This simply catches all the inputs that don't fit within the program's main cases. It's very similar to an else case at the end of an if-else chain. Now, why are these statements so useful? Well, many times, programmers want their programs to function differently depending on different conditions. For instance, a program could function differently depending on the information that the user inputs, such as allowing a user to use a program or not use a program if they are above or below 18 years old, respectively. Or in, say, a video game, if a user's experience is above a certain threshold, we might want to give them harder opponents to battle. Another example could be a program which changes the color scheme depending on the time of day. Or even more simply, if a user presses a button that is meant to move on to another screen in an app, the programmer would only want that app to change screens if the user clicks that button. A program without conditional statements would do the same thing every time, and would be very primitive compared to one that can change depending on its conditions.
So now that we know how to make and use variables, how to compare them, and what we can do with those comparisons, let's move on to another foundational concept of computer science, and that is arrays. Now we've already talked about variables, and how great they are for storing singular bits of information for making our code more simplistic. But one of the biggest drawbacks that comes with variables is their inability to hold more than one piece of differing information. For example, let's say you're making an app which allows a user to create a grocery list. Well, there's no real easy way to create lists using variables, because it's not like you can have one variable store the names of 6 or 7 different food items. Remember, we can only put one piece of paper in our cardboard box, no more. And besides, even if you were able to add multiple items to one string variable, You would still have a lot of trouble doing simple tasks you might want from a list, such as searching through it, splitting it, or even deleting items from the list when you're done with them. This is the problem that using arrays solves for us. An array is, as you may have guessed by now, a list. You can have an array of integers, an array of strings, and even an array of other arrays, which is something we'll cover in a minute. Programmers use arrays when they want to store a lot of variables containing information that is all related to each other, such as a grocery list or a high score list in a game. Think of arrays as a column in Excel or Google Sheets. You have the title at the top, and then below it are a bunch of bits of information which all relate back to the title. Arrays are super useful when programmers want to store a lot of information that can be easily searched through, because programmers have developed methods of breaking down and using arrays to find specific information in arrays full of thousands of different variables. As an example to show just how useful arrays are, let's say you're a startup company that owns an app that has 100,000 users. Every time a user wants to create a new account, they input the username they want, and then your program will have to check to make sure the account name hasn't already been taken. Doing this requires you to search through the information of all 100,000 of your users to see if that username has an account with your service. An array would be able to contain all of this information and make it easy to search through and find out if the account name has already been taken, with little to no delay. Now, the single most important thing to note about arrays is how you reference each element of the array within them. Let's create a basic array called numbers, and inside of it put the digits 1 through 10. Now, when we want to refer to each cell in this array, we would call upon its index. An index is just a fancy way of saying that number's place within the array. Now, you would think that the first integer in this array would be the first index, the second would be the second index, and so on, but that's simply not the case. In computer science, programming languages refer to the first cell as the 0th element in the array. This means that if we were talking about our array of numbers we just made, the number 4 would actually be in the third index, 5 would be in the fourth, and so on. So instead of starting our count from 1, we start from 0. It's extremely weird and confusing, but it's one of those programming quirks you're going to have to memorize and commit to memory. If you were to not follow this nomenclature and refer to the last element in this array as the 10th, you get what is referred to as an array out of bounds error, since you're trying to reference the 10th element, but there is no 10th element. What you're actually trying to do is reference the 9th element. Another extremely important thing to note about arrays has to do with their size. When you initialize an array, you can do it in either one of two ways. You can either populate it with the elements that you want contained in the array right then and there, creating and filling the array at the same time, or you can define how many elements you want the array to hold, essentially the array's size, and then populate it with elements later. This is because when we initialize an array, it creates a space in memory that has the size of exactly what you give it, no more and no less. This is great for when we want to access elements in the array because we can do so instantaneously because the computer knows exactly where in memory the array is stored. But the one downside is that we can't increase the size of the array later on. All array sizes are final. Think of this like setting up a bookshelf with books. By populating a bookshelf with a certain number of books and then moving on and filling the next shelf with different books, we have no way to go back and add books to that first shelf without shifting everything over. Once we decide how much space to dedicate for an array in this case, there's no way to add more space. Once again, because this is extremely important to remember, this means that once an array has been defined, there is no way to change the size of it. If you have an array titled names with a size of 8, and you try to add another name to the array, you will receive an error. So be careful when messing around with array sizes. Of course, you can always go back to the start of your code, when you initially make the array, and allocate more space to it, increasing its size, if you find out that you need more space to hold items. But once it's defined, you cannot change its size through conventional methods. Another small thing I want to touch upon really quickly is that when you initialize an array, you must determine which type of array it is right then and there. For example, you have to specifically say it will be an array of strings or integers when defining it. And also, you're not allowed to mix and match, meaning that you can't have an array full of integers with a few strings and some doubles thrown into the mix. They all have to be the same type. Now, the last thing we're going to cover on arrays is a little funky, and that is the practice of putting arrays inside of arrays. If you make an array of arrays, it is referred to as a 2D or two-dimensional array. Think of these as matrices if you have taken an algebra class before. Now, if you haven't, think back to our Google Sheets example. But instead of using columns, we would add rows as well. So now each element in an array wouldn't simply just be a string variable or an integer variable, but an entirely new array with its own set of values and elements. The way we index these is mostly the same, except we would have two numbers to index instead of one. We start with the row and then the column. So a number in the position 0, 2 would be in the first row, 3 columns down. In this case, the name Clint. A number in the position 1, 1 would be 2 rows down and 2 columns across. In this case, the name Chris. You get the idea. Now you can also make three-dimensional arrays by putting an array inside of an array inside of an array, but that's a little above what we're going to be covering, so I'm going to cut it off there.
Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Well, as you could probably tell by that statement right there, a programming loop is a statement that is used to run certain instructions repeatedly, just like how the opening statement of this topic was repeated 5 times. Loops are very useful for a variety of reasons. For instance, imagine you want to print something 15 times. Sure, you could just copy and paste the print statement 15 times, but this is really annoying to have to do, and becomes even more unrealistic when that number goes up to, say, 100 or so. Now, what if instead of rewriting the same instructions over and over again, you could simply place the print statement inside of a loop, and it will occur as many times as you would like. Now that's the power of loops. With loops, we're able to repeat parts of code multiple times. Now there are 3 different types of loops that we will be discussing today, and up first is the for loop. A for loop is very useful for situations like the one described above, where you would like to carry out a certain set of instructions numerous times. The syntax for a for loop varies depending on the language, however it usually consists of 3 parts: an integer value, a condition which the integer value must meet in order to exit the loop, and an operation to modify the integer value after the instructions inside of the loop are completed. Each time the for loop runs, the operation you set will be performed on the integer, and as long as that integer still meets the condition you set, usually being greater than or less than a constant value, the for loop will continue to run. Eventually, when the integer has been modified by either increasing or decreasing it to the point where it no longer meets the condition, the for loop will terminate and the code will continue to run. For example, let's say our integer value is I and we set it equal to 0. Then we set the conditional statement as I being less than 3. So basically we're saying that as long as I, the variable we just created, is less than 3, continue running the instructions contained within the loop. Finally, we make the operation I++, meaning each time the loop runs, we will increase it by 1, and inside of the loop, let's just put a simple print statement. Now, let's run through the for loop. We start with I equals 0. 0 is less than 3, so we enter the loop and print out hello world. Now that the instructions are done, we add 1 to I, making it 1. Moving on, 1 is again less than 3, so we once again enter the loop and print out hello world. Again, we add 1 to I, making it 2 now. 2 is still less than 3, so we enter the loop again and print out hello world. Finally, we add 1 to it once again, and it becomes 3. 3 is not less than 3 though, it is equal to 3, and so we don't enter the loop and it terminates, moving on to the next segment of code. This is a simple example, but you can extrapolate it across programming to fit your needs. Now, when using a for loop, you have to make sure to set up a condition that, given the initial integer value and the operation, will at some point not be met, to avoid creating an infinite loop and crashing your program. An infinite loop occurs when you give a for loop a condition which will always be met given the parameters of the program, and so the software crashes. For example, a for loop beginning at 10 and checking if I is ever less than 0, and then adding 1 to I at the end of the loop will never terminate since I will just increase infinitely. After the for loop is the very similar for each loop. A for each loop, or a for in a list loop in Python,